नहीं बोर्ड कहाँ है ये मैं क्या लिख रहा हूँ मुझे भी वहाँ चाहिए वो मेरी hotness gone. Okay. Yeah, good afternoon, students. So yesterday we did determinant sums and Cramer's rule also we did, right? So Cramer's rule, okay, that is fine. Today we'll finish off all determinant sums and we'll be going for then we'll go for again matrix inversion method and Gauss-Jordan method. Okay, so okay, fine. Gauss-Jordan method is little bit tough. So let us go for again few determinant sums which are very, very important. Exam point of view. Is it clear? Right. Okay then. Okay. Now, very important sum. It was asked so many times. Is it clear? Show that. Show that. Determinant of A, B, C, B, C, A, C, A, B whole square that is equal to determinant of 2BC minus A square, C square, B square, correct? And C square and 2AC minus B square and A square. And A square. Here it is B square, A square. Okay. B square, C square, this is B square and A square. 2AB minus C square. This what I have to show is A cube plus B cube plus C cube minus 3ABC whole square. Okay. Now see the solution, everybody. See the solution, everybody, which is very, very important. Right. Now I'm going to take the determinant A, B, C, B, C, A, C, A, B. Its whole square. Now let us expand this determinant. Let us expand this determinant. Yesterday I was telling you, right? This is nothing but plus, minus, and plus. We are expanding the determinant along with the first row itself. So that is nothing but plus A into, leave the row and column, it is present, BC minus A square minus B into, leave the row and column, it is present. So what is the row and column? It is present actually. The row and column, it is present once again. So B means leave the row and column, it is present. So B square minus AD minus BC form always. AD minus BC like that. Okay. Right. Okay. Minus B into, it is B square minus AC. Next, plus C into, leave the row and column, it is present. It is AB minus C square. But this whole thing is under the square, right? Because I'm having whole square here. So it is whole square. That is nothing but ABC minus A cube minus B cube minus into minus plus ABC minus C cube, its whole square, right? Which is nothing but ABC plus ABC plus ABC. 3ABC minus a B cube minus A cube minus B cube and its whole square. Now I can take minus common. Take minus common, then A cube plus B cube plus C cube minus 3ABC, still its whole square. But because of even power, this minus becomes plus, which is nothing but A cube plus B cube plus C cube minus 3ABC, its whole square. See, when I took this part, I got this result, correct? When I took determinant of this ABC, BCA, CAB whole square, I got this result, which is directly I got this third result. Now, once again, I'm going to take the same result. Now I'm going to get this result. So what I'm trying to tell you is 1 equal to 2 equal to 3. What we have to prove? Let it be this is 1, this is 2, and let it be this is 3. So what we prove is 1 equal to 3 I prove and 1 equal to 2 I prove. So ultimately 1 equal to 2 equal to 3. Is it clear? This is what we are going to prove. Okay. So first 1 equal to 3 has been done. Check it. This is 1 and that is your 3. So 1 equal to 3 I proved it. Next we are going to prove 1 equal to 2. Right? I hope you understood. This is your determinant expansion directly. Whole square is there. So you expand your debt normally, whole square. Then what you will get is 3ABC minus A cube minus B cube minus C cube. Take minus common, its whole square. Because of even power, the minus becomes plus. Okay? Right. Now, once again, 1 equal to 2 I said. Once again, I'm going to take ABC. Once again, I'm going to take A, B, C, B, C, A, C, A, B whole square. Previously, I was expanding this determinant directly. Previously. But now what I'm going to do is, right, this is whole square only, no? Every determinant is nothing but like a matrix only. Okay? Determinant is nothing but a particular value of the given matrix. Is it clear? Right? So that is A, B, C, B, C, A, C, A, B into, right? Because of whole square, no? Like whenever I'm having A square, we'll write it as A into A, no? Same way, right? So it is A, B, C, B, C, A, C, A, B. Is it clear? Right. I wrote it into square. I wrote it into two parts. That is A square. How we are writing A into A. Same way we wrote there. Okay. Now, that next step is very important step. According to determinant properties, when I interchange two rows, whenever you interchange two rows, your determinant will affect with only negative sign. Means before interchanging the rows and after interchanging the rows, only the सर इसको व्हाइट बोर्ड बनाएंगे, व्हाइट बोर्ड, व्हाइट बोर्ड, बोर्ड। तो पीछे क्या गया? तो पीछे का सम चाहिए। हाँ, रहने दीजिए। Okay, let us continue. So I am going to take now, whenever I interchange two rows, your determinant will affect with 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 always minus. Is it clear? So that is the thing. Your determinant will affect with minus. So your determinant value will be same. Is it clear? Same determinant, only minus will affect. So here I am going to interchange. Have a look. ABC, BCA, CAB as it is, right? Now I'm going to interchange. So I said just now, whenever I interchange, I get minus. Everything is product only. ABC, CAB, BCA. So I interchange your C2 to C3. I mean R2 to R3, R3 to R2. Interchanging R2 to R3 and R3 to R2. So I interchange. So whenever I interchange any two rows or any two columns, I am going to get a negative sign outside the determinant. Is it clear? That is the only difference. Now that negative sign, now we are going to ABC, BCA, CAB. That negative sign I am going to multiply to the first row. Minus A, minus B, minus C, CAB, BCA. Here you are going to do matrix multiplication. What you are going to do? Matrix multiplication. Yeah, determinant is there, but every determinant I said is nothing but a matrix only. From matrix only you will get a determinant of a matrix, we say, no, which is nothing but a particular value. That's all. Okay. Now we are going to do matrix, matrix multiplication. And I hope little bit 3 by 3 matrix multiplication. I hope you know, right? And here also I will do once again. No need to worry about that. So once again, I will write these two as it is, and I will start matrix multiplication in next board. That is nothing but ABC, BCA, CAB into minus A, minus B, minus C, and CAB, next BCA. Now, please do matrix multiplication there, students, right? First row with first column, that is this first row, the first row with first column. See, this is your first row with first column, right? That is minus A square, B into C, that is plus BC. Next, C into B, again plus BC only. Is it clear? Next, first row with second column, that is minus AB, that is nothing but minus AB. Next, plus AB plus C square. See, first row, whenever it is done with all three columns, you have to write it in first row itself. So first row with third column, right? Matrix multiplication, minus AC plus B square plus AC. See, first row with all three columns has been done. Now, second row I'm talking about. Second row with first column. What is that? Minus AB plus C square plus AB. Next, second row with second column. Minus B square plus AC plus AC. Just you have to multiply the corresponding, B into minus B. Second position to second position. The third position to the third position of first, second row, first column, second row, second column, second row, third column. Now same second row with third column. What is that? Minus BC plus BC plus A square. See, your second row with all three columns has been done, and you are going to write it in second row only in the resultant matrix or determinant. Now third row with first column, minus AC plus minus AC plus AC plus B square. Next, here minus BC plus A square plus BC. Next, C square plus AB plus BC. Is it clear? That is the thing. Now, have a look here. BC plus BC, 2BC minus A square. Here AB gets cancelled. What I get is C square. Here AC also gets cancelled. B square I get. Right? Here this gets cancelled. Here these two, and here these, and here these two gets cancelled. So what is left out is C square. Here 2AC minus B square. Here A square. Here B square. A square. Yeah, it is minus C square plus AB only here. Okay. Plus AB only, right? So it is nothing but 2AB, right? 2AB, it is minus C square here, C into minus C, okay, minus C square, right? So C square, see, which is nothing but, according to your question, what I said here, according to the question, first I took this, I proved this. Next, I took this, and I'm going to prove this part. Is it clear? Now, this I took, and I'm going to prove this part that we did already here. Is it clear in this board? So therefore, your answer is what? That is ABC, BCA, CAB whole square, that is equal to 2BC minus A square, C square, B square, and this is C square, 2AC minus B square, and A square, and here B square, A square, 2AB. That is 2AB minus C square, which is equal to A cube plus B cube plus C cube minus 3ABC whole square. Is it clear? So this is what we have to prove, and just now we proved it. Okay, right. So I hope you understood. Once again, you can have a look everywhere. Once again, all the slides, right? So first 1, 2, 3. First, what I did, I took 1 and I proved 3. I took 1 and I proved 3. This is your 1 and 3 part. Correct? Next board, I took again 1 and I took square, I took it as into 2 determinants. I interchanged this and this, row 2 and row 3, so that I get minus outside according to determinant properties. That minus I multiplied to first row. Then next board, matrix multiplication, and that matrix multiplication, easily you will get the things. Is it clear? And you should know your basic matrix multiplication so that you can get your result. Okay, right. Next, most important thing, once again, if this also was given, A square 1 plus A cube. Next, B square 1 plus B cube. C square 1 plus C cube. This equal to is given as 0. And your question is, and A square 1, B square 1, C square 1 is not equal to 0. Then what is asking us to show? Then show that सर ऊपर चले गए सर, बोर्ड सफिशिएंट नहीं होता सर। ये देखिए, ये यहाँ देखिए सर, ऊपर का कट हो गया, सफिशिएंट नहीं होता, एग्जैक्टली आना चाहिए। यहाँ देखिए, पूरा नहीं आ रहा, देखिए। हाँ, बोर्ड उसको एडजस्ट करिए थोड़ा। हाँ, वाइस। Okay, then show that ABC equal to -1. What we have to show, right? Okay, see the solution, everybody. So what he has given is, please follow the same steps. How I am doing on the board, as it is you are going to do in exam hall, right? A square 1 plus A cube, B square 1 plus B cube, C square 1 plus C cube equal to 0. This is your given thing. Is it clear? Now, according to determinant properties, if I am having some of the elements in either column or row. So here I'm having some of the elements in third column. So according to the determinant properties, I can split the determinant into sum of two determinants, right? That is a square 1, b square 1, c square 1 plus, because I'm having plus in between them now. See here, I'm having plus here, see, plus, plus, plus. So you are going to split the determinant, you are going to split the determinant for the, you are going to split the determinant for the third column. Is it clear? Like sum of two determinants. And remaining two columns as it is, you will write. And in third column, you are going to write it as 1, 1, 1, plus again, it is a square, now a cube, b square, b cube, right? c square, c cube, that equal to 0. Once again, I am telling you, according to the determinant properties, split the determinant into sum of two determinants. If at all you are having some of the elements. See, these simple small things, if you are able to know little bit, easily you can do in exam without any confusion. Is it clear? Yeah, after doing this separation, see, I split the whole one determinant into sum of two determinants by splitting your third column. Like 1, 1, 1 and a cube, b cube, c cube. C1 and C2 as it is I wrote. Okay. Now, here nothing is there to do. But here I can take A common from first row, B common from second row, C common from third row. According to determinant properties, if there is something common either in row or column, there is a possibility of taking outside, you can take it out. So that only I'm going to do in next board. Right? Okay, here only I will write. So what is that? That is determinant of a square 1, b square 1, c square 1 plus, yeah, I'm writing little bit small so that everything, if it look like in one board, then easily you can do the things. Is it clear? Sir, ये बोर्ड यहाँ मुझे नहीं आ रहा, ये बोर्ड कैमरा एडजस्ट करिए थोड़ा. कैमरा एडजस्ट करिए, पूरा बोर्ड नहीं आ रहा, हाफ बोर्ड आ रहा, वही देखो. यहाँ मुझे प्लेस है, यहाँ नहीं दिख रहा. थोड़ा इस तरफ और थोड़ा. Now plus, is it clear? Now plus, see here, I said I can take A common first row, B common from second row, C common from third row, because there is a possibility of. So what I'm going to get? A, B, C. Then what? Suppose when I take A common from first row, what I will be getting here? 1, A square, correct? Next, B common from second row, 1, B square, because I took 1 B outside. So 1 here, B square means 1 B will be left out. B cube means B square will be left out. Is it clear? 1 C square, right? Still that is equal to 0. Now, yeah, next step I will do in next board. Right, have a look. These two determinants, they don't look like same. Correct? No? These two determinants, they don't look like same. So what I'm going to do is, I'm going to make it same by interchanging the columns. Have a look once. So this is nothing but A square 1, B square 1, C square 1 plus ABC I took common. When I take ABC common, what I got actually? 1 A square, 1 B square, 1 C square equal to 0. Now these two don't look like same, just now I said. So that is nothing but A square 1, B square 1, C square 1. Now I'm going to interchange. C1 interchange it to C2. Now just now I said in previous problem also, whenever two rows or two columns are interchanged, I'm going to get 1 minus. What I'm going to get? 1 minus outside the determinant. Your determinant value will be, value means absolute value will be same. Your sign will change. that is C1. So your C1 means here I get A, B, C. This is C1 students. This is C2. This is C3. Row columns I'm talking about. Is it clear? Right. So next 1, 1, 1. Next A square, B square, C square equal to 0. But still it won't look like the same. Now what is the difference? Here A square, B square, C square I'm having in second row, second column, and 1, 1, 1 in third. But here it is in opposite. So what I'm going to do is again A square 1, B square 1, C square 1 plus A, B, C. 1 minus is there. Now again I'm going to interchange C2 to C3. Is it clear? Interchange column 2 to column 3. What I'm going to get then? That is nothing but one more minus I get, correct? Because I'm interchanging. Now what I'm going to get? A, B, C as it is. Now here I get A square, B square, C square, and 1, 1, 1, which is still equal to 0. Now have a look. Now is these two determinants look like same? See, you can have a look. A square 1, B square 1, C square 1. Here also A square 1, B square 1, C square 1. Now it looks like same. Now is this minus into minus, it becomes plus. Now in next board, I'm going to take common. What I'm going to take common? A, B, C, right? Next A square, B square, C square. 1, 1, 1. I'm going to take common. Whenever I'm going to take common, this and this, if I'm going to take common, by default, I will be having 1 here, right? So 1 plus minus into minus plus, it becomes ABC. Is it clear? So that is nothing but 1 minus into minus plus it becomes ABC, which equal to 0. But in what is given in the question, that determinant of A square 1, B square 1, C square 1 is not equal to 0. Therefore, definitely 1 plus ABC must be equal to 0 and your ABC equal to minus 1. Yeah. Anyway, you can see the board, right? And you can, after the class evening also, you can revise once whatever the explanation has been done. Once again, you can do revision. You can see the videos, right? So listen carefully, and I hope you understood. So this is your one of your most important long answer. Is it clear? Right. Next. This one also asked in, especially he asked this question in 4 mark. Yeah, matrices. I will finish off 7 mark, 4 mark at a stretch. Then we'll go for next chapter. Is it clear? All right. Next, show that this is also important. It has given in 4 mark also. A square plus 2A. 2A plus 1 and 1. Next, 2A plus 1. A plus 2, 1. 3, 3 and 1. That what we have to show? A minus 1 whole cube. In yesterday's class, I said, whenever I'm having ones in column, please apply row operations. Whenever I'm having ones in column, anywhere, any column, please apply row operations. If ones are in row, please apply column operations to make 2 of them 0. To make 2 of them 0, so that you can easily expand your determinant. Is it clear? So never expand the date directly. Complete simplification, maximum operations, then only you can do your then only you can expand your determinant. Is it clear? Now, once again, I'm writing the solution. You can have a look. Take your LHS determinant. 2A plus 1, 1. 2A plus 1, A plus 2, 1. 3, 3, 1. Now, the operation, what I'm going to do is, have a look. C column, sorry. Here, what I said just now, the ones are in column. So, do row operations. R1 tends to R1 minus R2 and R2 tends to R2 minus R3. Is it clear? Let us apply that part. What happens? Yeah, never do calculation part inside the determinant. Okay. If you want R1 minus R2, this is your R1, this is R1, this is R2, and this is your R3. So R1 minus R2. Have a look. A square plus 2A minus of this. So minus 2A minus 1. Is it clear? I will change the color. A square plus 2A minus of, okay, minus of this. So minus 2A minus 1. Is it clear? Minus 1. Next, come here. Same, complete R1 minus complete R2. So 2A plus 1 minus A minus 2. 1 minus 1 is 0. Next, R2 tends to R2 plus R2 minus R3. That is 2A plus 1 minus 3. Next, A plus 2 minus 3. Next, 1 minus 1 is 0. Your third row will be as it is. Your third row will be as it is. Is it clear? Now, let us see simple. Let us simplify whatever I can. Now, 2A gets cancelled. So, what I'm having here, A square minus 1. Next, 2A minus A is A. Plus 1 minus 2 is minus 1. 0 as it is. Simplification of your first row has been done. Next, 2A minus 2. A minus 1. 0. Next, 3, 3, 1. Is it clear? Now, A square minus 1, I can write it as A plus 1 into A minus 1. Correct? A plus 1 into A minus 1. Okay? Here A minus 1 as it is 0. Here I will take 2 common, A minus 1. Simplification, right? Your logic part has been done. Now, only what you are going to do is proper simplification. Now, this is 3, 3, and this is 1. Is it clear? Now, in next step, can I take, see, just now I said, if you find anything common in any row or column, you are going to take it out, right? So here, what I can see here, what I can see the common part, A minus 1, A minus 1. By default, 0 into A minus 1, anyway, it will be there. By default, 0 into A minus 1, it will be there. So I can take A minus 1 common. I can take A minus 1. 1 A minus 1 common from first row. Same. 1 A minus 1 common from second row, A minus 1. Please write the determinant. What is left out? So that is 1A plus 1 is left out, 1 and 0. Correct? No? Because I took A minus 1 common. Next, 2 will be left out, 1 and 0. And this is 3, 3, 1. I hope you understood the operations, whatever I did. And सर ये नहीं दिख रहा सर मुझे अब मोबाइल में देख रहे ये नहीं दिख रहा देखो आप और थोड़ा पीछे करिए right. So this is what you are going to get. Now next. Okay, so this is what you are going to get it. Now still one more step is the last step, right? That I am going to do next page. Now A minus 1 into A minus 1, what happens? A minus 1 whole square, A minus 1 whole square into determinant of A plus 1, 1, 0, 2, 1, 0. Okay, A plus 1, 1, 0, A plus 1, 1, 0, 2, 1, 0. This is 3, 3, 1. Still, I can do some operation. What is that? R1 tends to R1 minus R2. Sir, how to know that we have to do one more operation? Most important thing, try to get maximum number of zeros. Is it clear? So, when I do this operation, what happens? A minus 1 whole square. Have a look. R1 again. R1 minus R2. So, A plus 1 R1 minus 2. Again, 1 minus 1, 0. By seeing these two, By seeing these two, I made R1 tends to R1 minus R2. Is it clear? Now, and this is 0 as it is. Now, 2, 1, 0, 3, 3, 1. Now, expand your determinant. Expand that along column 3 because already 2 zeros. Okay, you do one thing. Expand your determinant with column 1 only. Why confusion? Always you do that only, no? Expand that along R1. Okay, that is nothing but a minus 1 whole square. Little bit one more simplification. A minus 1 0 0 2 1 0 3 3 1. Now expand your that along column 1. A minus 1 whole square into a minus 1, right? A minus 1. So leave the row and column, it is present. Leave the row and column, it is present. That is, once you have a look, this is the row and this is the column in which it is present, no? AD minus BC. 1 minus 3 into 0 is 0, which is nothing but a minus 1 whole square into a minus 1, which is nothing but a minus 1 whole cube. So this is also important for 4 mark. Is it clear? Yeah. So this is what it goes for 4 mark. Next, I hope you understood, right? Everything will be there here. Afterwards, you can once again revise the things. Now, this is again important for 7 mark. Show that determinant of A, B, C. A square, B square, C square. A cube, B cube, C cube. Okay? A, B, C, A square, B square, C square, A cube, B cube, C cube. Very important, students, very important. Now, today, whatever the determinant sums I said, all are important. And this determinant sum, sir, थोड़ा blur आ रहा ना sir? आपके मोबाइल में okay. Okay, this what we have to prove. I mean, what we have to show that ABC into A minus B, B minus C, C minus A. Okay. Now, once again, I am going to take A, B, C, A square, B square, C square, A cube, B cube, C cube. That is equal to. Again, same concept. When you are able to see something common in row or column, you have to take common, I said. So in first column, I can see A common, correct? In first column, I can see A here, which I'm going to take A common. Second column, B common. Third, C I took common. ABC I took common. And I take ABC common, what I'm going to get? 1 will be left out here. Here A square means A square. 1, B square. 1, C square. Correct, no? We took ABC common. Once I take ABC common, now you got 1s in what? Row. Then I said to do column operations. ABC. So here I am writing column operations. The ones are in row. So apply column operations. C1 minus C2. C2 tends to C2 minus C3. Correct? So that is nothing but determinant of row column. This is your column. So one. Column is this. So 1 minus 1, 0. A minus B, A minus B. A square minus B square means C1 minus C2. Next, C2 minus C3. 1 minus 1, 0. B minus C. B square minus C square. Next, 1 C square as it is, I will write. See, I got 2 zeros already. Correct, no? And now ABC 1 0 0 1 as it is. Now whenever you find 1 in column or row, if I find 1s in row, apply column operations to make them 0. If I find ones in column, apply row operations to make 0. Now, the ones were in row, I made column operations, I made them zeros. Now, here, a minus b, a square minus b square, I will write it as a minus b into a plus b. Here, right? So, now, again, 0, 0, b minus c, b plus c into b minus. Now, 1 c, c square. Okay. Now, according to determinant properties, if something is there common, you take it outside. So, what is common here? Your common is, by default, I will have 0 into a minus b and a minus b. Here, b minus c, 0 into b minus c, b minus c. So, take out common b minus c and a minus b from column 1 and column 2. That is a minus b, b minus c, I took it common. Now, left out part, you are going to write 0, 0, 1, 1, 1, c, correct? Here, a plus b, b plus c, and c square. Still, I said just now, 2 zeros I got, okay, that is fine. Now I'm going for one more operation to make again 0. That is C1 tends to C1 minus C2 again. C1 tends to C1 minus C2, right? So, okay, I'm going for next board. Right? Now, in that next board, I'm going to do ABC, A minus B, B minus C as it is, you write. So, that is nothing but ABC, A minus B, B minus C as it is. Determinant of 0, 0, 1, 1, 1, C. Determinant of 0, 0, 1, 1, 1, C. Right? Next, A plus B, B plus C, C square. A plus B, B plus C, C square. Okay. Now, okay, that operation what I did there, C1 tends to C1 minus C2. Please apply the operation A minus B, B minus C into. Now, 0 minus 0 doesn't make any difference, 0. But here 1 minus 1, it makes the difference. 1 minus 1 is 0. Next, A plus B minus of, correct? So what I'm going to get, BB gets cancelled, A minus C. Then 0, 1, B plus C, 1, C, C square. Okay, now that is ABC, A minus B, B minus C. Please expand the determinant for row 1. Is it clear? Anyway, first two are zeros. So 0 into anything minus 0 into anything is 0. Plus 1 into, leave the row and column, it is present. That is AD minus BC. So 0 into B plus C minus 1 into A minus C. That is nothing but ABC, A minus B, B minus C. Now, plus 1 is okay. Here I am going to take minus common because in your question, RHS, what is asking is C minus A. So take minus common there. So that is plus 1 into C minus A. I took C minus A minus common or minus you multiply inside, whatever. That is nothing but ABC, A minus B, B minus C, C minus A. That is the thing what is asking there. I hope you understood, right? And this will be the last determinant sum. I mean, 2 more determinant sums are there. With that, your almost all, whatever the determinant sum is going to ask, everything has been covered. All are important. Every year is asking one of the determinant sum, either something or the other, every time. Okay, right. Very important determinant sum, determinant of 1 A square A cube, 1 B square B cube, 1 c square c cube is equal to what I have to prove? Yeah, this will be little bit b minus c, c minus a into ab plus bc plus ca. Once you know the cube formulas, then it's easy to do. But when you see directly, sometimes you may feel difficult this sum, but it's okay. Now the ones are there in column, correct? Where are your ones are? The ones are there in column. That is 1, 1, 1, a square, b square, c square, a cube, b cube, c cube. Right? Means you are going to apply row operations. That is R1 tends to R1 minus R2, R2 tends to R2 minus R3. So that is determinant of 1 minus 1 is 0. A square minus b square. A cube minus b cube. 0. B square minus c square. See the operations. B cube minus c cube. 1 c square c cube as it is. Is it clear? Now, here 0. Here I am going to write it as a minus b into a plus b. And this is a cube minus b cube formula. A minus b into a square plus ab plus b square. Is it clear? That is nothing but b square. Next, 0, b minus c into b plus c. B minus c into b square plus bc plus c square. 1 c square c cube. Is it clear? Now, 0 into a minus b, a minus b, a minus b. Take a minus b common. 0 into b minus c, b minus c, b minus c. B minus c also I can take outside the determinant. Is it clear? Now 0, a plus b, a square plus ab plus b square. 0, b plus c, 1 c square c cube. Okay. Now one more operation is very important here. That is R1 tends to R1 minus R2. Means 0 minus 0, this minus this, this minus this. You be careful. Once you do this one, rest everything will be easy. Okay. So once again, anyway, it's a video only, no? I'm going to erase this part because next board carrying is difficult, right? So let us erase this part. Let us continue by seeing the same board. That is nothing but a minus b, b minus c is okay. R1 tends to R1 minus R2, I said. 0, 0, see. 0 minus 0 is 0 only. Here, a plus b minus b minus c. B gets cancelled. What I'm going to get here? A minus c. Next. Now this is important. The students usually where they will have confusion means this is the part. Have a look once, everybody. A square plus ab plus b square minus R2 minus of this means minus b square minus bc minus c square, correct? Now b square gets cancelled. Now what are the left out? A square minus c square, correct? A square minus c square is your left out. A square minus c square. Next, plus ab minus bc is left out. Okay, na? Write only. That one only I will write. So that is a square minus c square plus ab minus bc. Next, 0 b plus c, and this is b square plus bc plus c square, and this is 1 c square c cube. Okay, now a minus b, b minus c into 0 a minus c. Now simplification of this is important. I will do outside, don't do there itself. Okay, here I will do. What is that simplification? A square minus c square plus ab minus bc. This I will write it as a plus c into a minus c plus b common a minus c. A minus c common, what I got is a plus b plus c. Is it clear? Right. So this I'm going to write it as a minus c into a plus b plus c. 0 b plus c, b square plus bc plus c square. One c square c cube. Is it clear? Okay. Now you are going to take from first a minus c, a minus c, a minus c common. When I take a minus c common, what I'm going to get? Okay, I hope you got this simplification, right? Don't do simplification. Yeah, that is nothing but a minus b, b minus c. Now expand your determinant along this column. 0 into any, sorry, before expanding, take a minus c common. A minus c or c minus a you take common. Then what is the determinant? It is left out 0. Here I'm having a minus c, but what I took is c minus a common. So minus 1 here also. Minus of a plus b plus c will be left out. Here 0 b plus c, b square plus bc plus c square. So, this is 1 c square c cube. Is it clear? That is nothing but a minus b, b minus c, c minus a. Anyway, this is 0, this is 0. So expand your determinant plus 1 into, leave the row column in which it is present. So AD minus into minus plus. So minus of b square plus bc plus c square minus into minus plus b plus c into a plus b plus c. Now simplify this, you will get your required answer. Okay, you do the simplification part. Still, if you don't get it, you can just refer, or tomorrow you can see the things. Okay, right. Tomorrow, so maximum your determinant sums are done. And tomorrow I'm going to do matrix inversion, consistency.